Good afternoon, everyone. Well, today I'm going to talk to you about astrobioethics and astrobiocentrism. To give it to you some little bit of context, this is part of a research we were doing with Stephen Dick, Tony Milligan, and Jesus Martinez Frias, and this kind of extraction resume of a paper. This is some kind of resume or extract of this research project we were writing with these colleagues, and we just sent it to a journal, Acta Astronautica. We got just good news because we received just only minor revision, so likely it's going to be published this year. And it's a work that I've been working with like 5 years ago. I started to work on this topic, astrobioethics, and now it's becoming kind of a great or a bigger topic currently. And that's why I titled this From Astrobioethics to Astrobiocentrism, Rethinking Human Responsibility in a Cosmic Context. So, astrobiology is a scientific discipline, as you may know, that studies the possibility of life in the universe. However, over time, its field of reflection has gradually expanded. It is no longer only about asking whether life exists beyond Earth, but also about thinking about the role of human beings play as we begin to expand into other space environments. In this sense, astrobiology does not only study life as a biological possibility. It also invites us to consider the scientific, ethical, legal, and social consequences of our presence beyond our planet. This expansion of the astrobiological field necessarily introduces an ethical dimension. If humanity explores other worlds, if it searches for life there, or if it intervenes in potentially habitable extraterrestrial environments, then we must ask ourselves what we should do, what we should avoid, and under what criteria we should act. This ethical reflection applied to the problems that arise from astrobiological research can be called astrobioethics. For this reason, astrobiology can also be understood as a transdisciplinary discipline. But what does this mean, and why is it so? To understand this, we must first consider that astrobiology brings together a wide range of disciplines. Documents such as NASA's astrobiology roadmap and contemporary astrobiology strategies show that this field includes knowledge from the natural sciences, the social sciences, and the humanities. Among these areas, we find biology, chemistry, astronomy, geology, law, philosophy, and ethics, among others. All of them are relevant, although they do not contribute in the same way or use the same methods. For example, studying the chemical composition necessary for life requires a very different approach from analyzing the philosophical consequences of finding life on other worlds. Both questions belong to astrobiology, but they are approached from different perspectives. On the one hand, the natural sciences are mainly oriented toward empirical verification. Their method depends on observation, measurement, experimentation, and available evidence in order to confirm or refute hypotheses. If we speak about extraterrestrial life, the only way to confirm its existence would be to find sufficiently solid, direct or indirect evidence of it. It is not enough to theorize about what it might be of, where it might have emerged, or whether it might be existed at some point on a nearby or distant planet. In other words, the role of the natural sciences within astrobiology is anchored in the search for empirical evidence. This is why disciplines such as biology, chemistry, astronomy, and geology play a central role in identifying conditions for habitability, biomarkers, extreme environments, and possible traces of life. On the other hand, the social sciences and the humanities play a different role. Their emphasis is not necessarily on discovering natural objects or processes through irreplicable evidence, but on interpreting, understanding, and building conceptual frameworks that help us make sense of certain events. This does not mean that they lack rigor. It means that their form of knowledge does not operate in the same way as physics, chemistry, or astronomy. In the social sciences and the humanities, we develop categories, interpretations, and theories to understand human, cultural, social, political, and moral phenomena. We do not find an ethical theory or a political theory in nature in the same way that we can detect a molecule or measure a temperature. Rather, we construct them in order to interpret reality and guide our actions within it. This point is especially clear in philosophy. Philosophy is not an empirical science, in the strict sense, because it does not base its claims on direct experimentation, nor does it seek replicability in the same way as the natural sciences. However, it fulfills an indispensable function. It allows us to formulate problems, clarify concepts, examine assumptions, evaluate arguments, and anticipate possible scenarios. For example, thought experiments, such as the trolley problem, do not describe a natural fact that must be measured. Instead, they allow us to analyze moral principles, responsibilities, and consequences of human action. In this sense, philosophy does not replace science, but it does help us think through its implications. Within philosophy, we find ethics, the discipline that studies the moral dimension of human action. Unlike the natural sciences, ethics does not need to wait until extraterrestrial life is confirmed in order to begin reflecting on the dilemmas that could arise if we were to find it. In this sense, astrobioethics can rationally anticipate possible scenarios derived from astrobiological research. This does not mean speculating without foundation. Philosophical reflection requires argumentative coherence, conceptual clarity, and respect for logical principles such as non-contradiction, identity, the excluded middle, and sufficient reason. Its level of abstraction may vary depending on the type of program being analyzed, but it must always be grounded in rational argumentation. In terms of probability, we know that most living beings on Earth are microscopic. Therefore, if life were ever found beyond Earth, one reasonable possibility is that it would be microbial life, especially if we consider that some terrestrial microorganisms, such as extremophiles, can survive very harsh environmental conditions. This consideration allows astrobioethics to work with relatively plausible scenarios, such as the possible existence of microbial life on Mars, Europe, Enceladus, or other environments within the solar system. The situation would be different if the concept of astrobiotical reflection were extraterrestrial civilizations. In that case, the level of speculation would increase considerably, because we would have to imagine formal social, political, technological, and cultural organizations completely foreign to our terrestrial experience. Moreover, this kind of reflection would reveal our own conceptual framework, which we could call biogeocentrism, the tendency to understand life in the universe based on the only confirmed reference we have, namely life on Earth. This life is based on chemical elements such as carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, known by the acronym CHOMS, almost like my last name, Chon, I'm OctavioChon. I always make a joke about that. If we add the possibility of intelligent life, then the Fermi paradox also appears. If the universe seems to offer so many possibilities for life, where is everybody? This kind of question makes the analysis more complex, because they force us to assume highly speculative scenarios in order to continue the reflection. By contrast, if we restrict the analysis to the possibility of finding terrestrial life within the solar system, especially on a nearby planet such as Mars, the scenario becomes more specific. This does not mean claiming that life currently exists here. It means recognizing that, based on advances in astrobiological research, it is legitimate to ask what we should do if one day it's confirmed that life once existed on Mars, or even more importantly, that microbial life still exists beneath its surface, for example. From the perspective of astrobioethics, we can anticipate this kind of situation and discuss which actions would be acceptable, which should be avoided, and what responsibilities humanity will have toward vulnerable forms of extraterrestrial life. For all these reasons, astrobiology cannot be understood only as a science oriented toward the empirical discovery of life beyond Earth. Its own object of study requires dialogue with disciplines that not only describe facts, but also interpret consequences, anticipate dilemmas, establish responsibilities, and propose normative criteria for human action in extraterrestrial environments. In this sense, its transdisciplinary character does not simply consist of bringing several disciplines together, but of articulating them around problems that none of them could solve it on their own. Astrobioethics emerged precisely at this point of convergence. While scientific evidence, philosophical reflection, moral responsibility, space law, and social impact must be considered in an integrative way. From this perspective, we can establish three main scenarios for axes of astrobioethical analysis: the legal, the moral, and the social. The legal axis refers to law and the norms that regulate human activity in space. The moral axis addresses the ethical criteria that guide what we should or we should not do in relation to possible forms of terrestrial life or environments with astrobiological value. And the social axis considers the impact that astrobiological discoveries or human expansion toward other worlds could have on culture, education, religion, politics, and the way humanity understands itself. So as for the first axis, the legal axis has to do with the regulation that should exist to guide, limit, and supervise the actions of private companies, for example, government agencies, and other actors involved in space research or activities with possible astrobiological implications, even when the search for extraterrestrial life is not the main objective. This is important because a space mission can have astrobiological consequences, even if its original purposes is technological, commercial, mining-related, touristic, or geopolitical. A spacecraft, a robot, a drilling operation, a return sample, or a human base on another celestial body could alter environments of great scientific and biological value. An important precedent is the Outer Space Treaty. For its time, this treaty was a fundamental basis for space law, since it established that the exploration and the use of outer space should be carried out for peaceful purposes, for the benefit of all humanity, and without national appropriation of the moon and or other celestial bodies. However, although the treaty mentions the need to avoid harmful contamination of celestial bodies, it does not explicitly develop astrobiological protection. In other words, it does not establish clearly enough what should happen if a human, robotic, state-led, or private mission puts at risk a possible form of extraterrestrial life, ancient biological evidence, or environment with favorable conditions for life. This gap is problematic because space activities no longer depends only on states. Today, private companies also participate with commercial, technological, and strategic interests. For this reason, astrobioethical regulation should apply not only to government agencies, but also to any private entity that could intervene in environments with astrobiological value. It is not enough for a company to declare that its mission is not searching for extraterrestrial life. If its activity could contaminate, alter, or destroy an environment that is relevant to astrobiology, then it should be subject to evaluation, authorization, and international supervision. Moreover, the legal problem is not limited to the existence of norms, but also to their enforcement. On Earth, international law already regulates what states should not to do, and yet these rules are not always respected. This allows us to imagine a worrying scenario. Even if a proper regulation existed to protect astrobiological interests, there will be no absolute guarantee that all countries or companies would respect those rules. A country with technological or military superiority could try to assert control over certain areas of the Moon, Mars, or other celestial bodies, especially if those areas have scientific, economic, or strategic value. A legal framework would only work if the participating actors respected international agreements related to astrobiological research, and if effective mechanism of oversight and sanction exists. However, what would happen if a country is not a part of a specific agreement, but does have the technology to reach the Moon, Mars, or a satellite to astrobiological interests, decided to intervene in or occupy a relevant area without considering its scientific or biological value? In that case, the countries that are part of the agreement would probably try to prevent it. But the effectiveness of that response would depend on the real strength of the available legal, diplomatic, and political framework. Today, if a private company were to send people to Mars or carry out research there and accidentally put an environment of astrobiological interest at risk, it would be compromising a unique opportunity to answer one of humanity's deepest questions, whether if we are alone in the universe. Biological contamination, poorly regulated drilling, or irresponsible intervention could destroy evidence of past or present life before it is properly studied. In that sense, the damage will not only be environmental or scientific, but also existential, because it would affect our ability to understand the place of life in the cosmos. For this reason, it will be necessary to think about planetary protection zones, like the ones I was hearing in this event early morning, or astrobiological sensitive zones. These could be classified into different levels. For example, first, there will be zones that contain possible elements for life, such as water, organic compounds, or sources of energy. Second, for example, there would be zones where life may have existed in the past. Third, there would be zones where the present existence of extraterrestrial life is confirmed, even if it's not only microbial. A fourth level could be also added, zones where the condition for future extraterrestrial life may exist, or where human intervention could modify natural processes relevant to its emergency or preservation, for example. This qualification allows legal protection not to depend only on the confirmed discovery of extraterrestrial life. Waiting until life is confirmed before protecting an environment could be too late. Astrobioethical regulation should operate under a principle of astrobiological precaution. Whenever there is a reasonable possibility of biological, scientific, or existential value, missions should act with prudence, transparency, and responsibility. The point would not be to stop exploration, but to prevent exploration from destroying what it seeks to understand. At this point, it is useful to distinguish between forward contamination and backward contamination. Forward contamination occurs when a mission carries terrestrial microorganisms into a extraterrestrial environment, altering its natural state of confusing future reserve or native life. Backward contamination occurs when a mission brings extraterrestrial samples back to Earth that could have unknown biological effects. Both cases should be regulated with strict protocols, because they involve both the integrity of other worlds and the safety of Earth's biosphere. In any case, we should already have effective ways to protect microbial extraterrestrial life or the environments where such life could exist. This attitude can be related to the idea of stilo empathy, if we use the Charles Kirk's terminology, for example, caring for the interests of extraterrestrial form of life that cannot care for themselves. In other words, if we ever find micro life beyond Earth, or even if there is only a reasonable possibility of finding it, humanity will have the responsibility not to destroy it, instrumentalize it, or contaminate it without sufficient ethical and scientific justification. A central question then arises: what kinds of sanctions should be applied if a company, agency, or country puts an astrobiological valuable environment at risk? Since this kind of damage could affect an existential question for humanity, sanctions should not be limited only to economic purposes. They could be legal, scientific, and diplomatic. First, there should be preventive measures, such as the temporary suspension of a mission, for example, the requirement of prior astrobiological assessment, or the prohibition of operations in sensitive zones if certain standards are not met. Second, corrective measures could be applied, such as the obligation to finance research aimed at repairing, mitigating, or monitoring the damage caused. Third, there could be sanctions in the strict sense, such as international fines, temporary exclusion from space projects, loss of authorizations, launch restrictions, or international responsibility for the state that allowed the activity. In this way, astrobiological regulation should operate on three levels: preventive, corrective, and sanctioning. The preventive level would seek to avoid contamination or alteration of environments with astrobiological value. The corrective level would require mitigation of compensation for the damage produced. and the sanctioning level would establish proportional consequences for those who violate the rules. This structure would make it possible for the protection of extraterrestrial life, or of the condition that could make it possible, not to depend only on the goodwill of the states, companies, or space agencies. Now, as for the moral axis, even there is no legal system that obliges us or tells us what we should or we should not to do when potential forms of extraterrestrial life are put at risk, we can still appeal to the precautionary principle. In this way, we can begin to understand what we should do and what we should avoid. At this point, one possible objection is that we may not leave any moral obligation toward alien microbial life, or that there may be no clear difference between caring for those microscopic forms of life and caring for the bacteria that already exist on Earth. In other words, what would be different if, in the end, they are not conscious or sentient beings? If they were forms of life capable of feeling, then we could appeal to the principle of equal consideration of interests, even in the absence of a specific legal regulation against the mistreatment of sentient beings. Since every sentient being avoids pain, its interest lies in not being made to suffer, and it could be our responsibility to avoid causing that kind of harm. If they have interest, we could even attribute certain rights to them. In that case, the argument would move in a different direction, parallel to the defense of animal rights, for example, but in a different context, of course, an astrobiological one. However, let us imagine a scenario in which we confirm the existence of extraterrestrial microbial life. These organisms would not feel, nor would they be capable of abstract thoughts. Therefore, eliminating them would not increase the universal suffering in any direct sense. In that case, the moral duty would not depend on whether they feel or think, but on what they represent, and on what, again, this teleempathy words means. According to the Encyclopedia of Astrobiology, teleempathy is the ability to recognize the interests of other extraterrestrial living things in the eventual case that their discovery is confirmed. For example, on Mars, if any form of microbial life were confirmed there, they would have no way to claim their own rights. So we, in an act of empathy that is not limited to terrestrial life forms, can watch over their integrity and avoid putting them at risk. So, this leads us to think beyond ourselves and places the moral axis on non-terrestrial microbial life forms. In addition, caring for, or at least acting with caution, in environments of high astrobiological interest allow us to think from a more cosmic perspective. In other words, it becomes a step toward a more astrobiocentric vision. Whether or not there are laws regulating how we should act toward the defenseless form of life, we would still have the moral duty to care for them empathetically. In some way, in relation to them, we are the guardians of life in the universe. If we do not care of it, who else could? Not all possible forms of life, of extraterrestrial life, would arise the same dilemmas. Finding fossil remains of microbial life would not be the same as discovering an active biosphere. Detecting a distant technosignature would not be the same as entering into contact with an intelligent civilization. For this reason, moral analysis must distinguish different levels of complexity, according to the kind of level found, its degree of vulnerability, its distance from us, its capacity for agency, and the possibility of interacting with it. From this perspective, we can consider the following scenarios. The first one is about active and defenseless microbial extraterrestrial life. In this case, the main moral responsibility would be to avoid its contamination, destruction, or responsible instrumentalization. Even if it were simple life, its value would lie in being an independent expression of life in the universe. The second one is microbial extraterrestrial life in a distant environment. Here, the moral dilemma is related to distance and to our real capacity for intervention. Even if we cannot interact with it directly, its mere existence would force us to rethink our ethical understanding of life beyond Earth. The third one is the fossil remains of extraterrestrial life. This one. In this scenario, the moral value would not lie in protecting a currently living organism, but in preserving unique evidence about the history of life in the universe. Destroying those remains would be a scientific culture and existential loss for humanity. And the fourth one, and the last one, or one of the following one, technosignatures from an extraterrestrial civilization, without the possibility of direct communication. Here, the problem would be how to interpret an intelligent signal when dialogue is not possible. The moral responsibility will be linked to prudence, the non-manipulation of information, and the evaluation of the social, political, and cultural consequences of announcing of or responding to such a signal. And then, when we have that, for this reason, the moral axis of astrobioethics cannot be reduced to a single question about whether or not we should protect extraterrestrial life. Rather, it must be built a scale of responsibility, according to the kind of life, the degree of possible interaction, and the relationship of power between humanity and whatever it encounters. The greater the vulnerability of the life form found, or the greater our capacity to affect it, the greater our moral responsibility should be. Social axis. The social axis of astrobioethics invite us to reflect on the cultural, historical, and existential singularity that finding life beyond Earth will represent. It would not be merely a scientific discovery, but an event capable of changing the way humanity understands life, its place in the cosmos, and its relationship with life in general. This possibility is not new. Already in antiquity, the idea of multiple worlds appeared in certain philosophical traditions. A reflection attributed to the Arabist philosopher Metrodorus of Chios in the 4th century expresses, before Christ of course, expresses this intuition clearly. It is unnatural in a large field to have only one shaft of wheat, and in the infinite universe only one living world. In other words, just as it could seem strange for there to be only one stalk of wheat in an immense field, it would also seem strange for there to be only one inhabited world in an immense universe. This phrase is usually attributed to Metrodorus, although some compilation warn that it is not always easy to verify its exact primary source, of course. Centuries later, during the Renaissance, Giordano Bruno would take up a similar idea by defending the possibility of an infinite universe without a single center, with multiple worlds and perhaps other forms of life. However, the historical context has changed radically. In the case of Metrodorus, we are dealing with a philosophical speculation typical of ancient atomism. In the case of Bruno, by contrast, the idea of multiple worlds was articulated within a religious, cosmological, and theological framework that was much more conflicted for his time. Bruno was tried by the Roman Inquisition and executed in 1600, not only for his defense of polarity of worlds, but also for several doctrinal positions considered contrary to the Catholic Church. This comparison allows us to introduce an important question for the social axis. Why can the same intuition, the possibility that other inhabited worlds exist, be received in such different ways depending on the time, culture, and dominant belief system? The difference does not lie only in the idea itself, but in the social system that interprets it. One society might receive the possibility of extraterrestrial life as an expansion of knowledge. Another might see it as a threat to its religious, political, and anthropological worldview. For this reason, the discovery of extraterrestrial life would not have only scientific consequences. It would also have deep social effects. It could transform religious discourses, philosophical narratives, cultural imaginaries, educational policies, public debates, and collective forms of identity. The question, are we alone in the universe, is not a purely astronomical question. It is also a question of who we are, what place we occupy, and how our self-understanding would change if we discover that life is not exclusive to Earth. In this sense, the social axis of astrobioethics studies how humanity could receive, interpret, and manage the impact of an astrobiological discovery. It is not enough to find life. We would also have to think about how to communicate the discovery, how to avoid misinformation, how to prepare society to understand it, and how to prevent it from being used irresponsibly for political, religious, commercial, or ideological purposes. This is especially relevant because the question of whether life exists beyond the Earth is millennial old and forms part of a long discussion about the plurality of worlds. For that reason, every announcement, rumor, or indication related to possible extraterrestrial life tends to mobilize public imagination and media attention. The current cultural relevance of UAP or UFO narratives, for example, is also nourished by the same expectation of not being alone, even when public belief and media interest may go far beyond what available evidence can support. Therefore, as long as there is no confirmatory observational evidence of extraterrestrial life, scientific communication must avoid categorical claims that exceed the available data. A recent case that helped us illustrate this dynamic is the terrestrial comet 3I Atlas. As you remember, the third confirmed terrestrial object detected by humanity. It was discovered in 2025 by the Atlas Telescope Network with observations made from Chile. What matters here is not to go into all its technical details, but to notice how a natural object coming from outside the solar system was able to attract enormous public attention. Although it posed no threat to Earth, its mere condition as an interstellar visitor was enough to activate expectation, speculation, a narrative about the possibility that we are not alone in the universe. Part of the public excitement around 3I Atlas was due to the fact that some of its images could lend themselves to striking interpretations, a tail, a visible coma, or structures that some presented as if they were signs of artificial behavior. However, from a scientific point of view, these features could be explained as natural phenomena, typical of a comet. The problem was not the object itself, but the way in which certain discourses quickly transform it into an extraordinary possibility without sufficient evidence, if you remember in the media. This dynamic show why the social axis is not a peripheral addition to astrobioethics, but an ethical responsibility that accompanies astrobiological communication. Researchers have the duty to communicate uncertainty clearly, avoid overinterpretation, and resist media incentives that reward dramatic dramas beyond the available evidence. A hypothesis may be legitimate, but it must be presented as a hypothesis. A possibility may be interesting, but it should not be communicated if it were a conclusion. A historical warning example is the Heaven's Gate movement. On March 26, 1997, 39 members of the group died by suicide in Rancho Santa Fe, California, after adopting the belief that a UFO was associated with the Hale-Bopp comet. Although Heaven's Gate was not led by professional astronomers, the case remains a concrete reminder that extraordinary astronomical phenomena can become focal points for extreme narratives, and that public as communication can have harmful consequences when uncertainty is replaced by suggestive certainty. For this reason, the social axis requires an ethical, disciplined form of public science. Claims should remain proportional to the evidence. Hypotheses should be clearly presented as hypotheses, and institutional voices should help distinguish between scientific inference, reasonable speculation, and media fantasy. This is especially important during events that attract high public attention, such as the passage of interstellar objects, the detection of anomalous signals, or announcements about possible biomarkers, while the limits of the available data can easily be exploited by sensationalist interpretations. On the other hand, the social dimension of astrobiological responsibility does not only involve preventing misinformation or moderating public expectations. It also makes it possible to build a narrative that connects different disciplines precisely because astrobiology is transdisciplinary, as I said before, by nature. In other words, the question of whether we are alone in the universe does not require only a biological answer, but also a reflection that includes concepts from astronomy, chemistry, geology, philosophy, ethics, law, education, and the social science also. In this sense, astrobiology offers a unique educational opportunity by working with problems related to life in the universe. Students, for example, can understand how different areas of knowledge come together around the same question. This makes it possible to cultivate transdisciplinary competencies through learning experiences linked to astrobiological researches. Sorry. Thank you. One example is this stratospheric balloon project I'm leading in Latin America with many countries, Paraguay, Colombia, Ecuador, Chile, and so. And why I'm showing this picture, this is a real picture of one of our projects. We're developing this project 10 years in a row in different countries, and we are making papers, publishing it. Well, this is interesting because we are developing with researchers, undergraduate students, where scientific experimentation, technological design, data analysis, collaborative work, and reflection on extreme environments as analogous of extraterrestrial environments are brought together. The social axis of astrobioethics shows that the search of life beyond Earth cannot be reduced to a laboratory, telescope, or space mission program. Its consequences reach cultural, educational, religion, politics, the media, the humanity's self-understanding. Finding extraterrestrial life, or even announcing a reasonable possibility of finding it, will be a scientific event, but also a social and existential one. For this reason, astrobioethics must ask not only how to investigate life in the universe, but also how to communicate it, interpret it, and prepare ourselves collectively to assume its implications. And now, almost for the final part, is the toward an astrobiotic vision. What is this new world astrobiocentric vision? The reflection that emerged from astrobioethics opened the way toward a broader vision of humanity in the universe. It is not only a matter of discovering life, of discovering whether life exists beyond Earth, but also of asking how we should behave in relation to that possibility. In this sense, astrobioethics allow us to move from a biogeocentric view, centered on life as we know it, life on Earth, toward an astrobiocentric view, one that understands life as a cosmic possibility and not as something exclusively terrestrial. To put it in analogous terms, just as the life we know depends on elements such as carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, and we use that basis to search for signs of life on other worlds, our moral reflection must also expand its starting point. Astrobiocentrism would imply moving from an ethics centered only on human interest toward an ethic capable of recognizing a broader moral community, one that could extend beyond Earth. This does not mean claiming that every form of extraterrestrial life will have the same moral value as human life, nor that we should stop space exploration out of fear of intervening or in other environments. Rather, it means that human expansion into the universe should not develop under a purely instrumental logic. Other worlds should not be seen only as resources, laboratories, available territories, or future extensions of Earth's economy. They could also be spaces with scientific, biological, historical, and eventually moral value. From this perspective, as an astrocentric vision does not deny the importance of humanity. On the contrary, it asks humanity to rise to the level of its own technological power. If we are capable of reaching Mars, sending probes to icy moons, analyzing the atmosphere of exoplanets, or altering extraterrestrial environments, then we must also be capable of asking what limits we should respect. The technical ability to do something does not automatically mean that we are morally authorized to do it. From this perspective, the astrobiocentric vision does not deny astrobiocentric purposes an expansion of our ethical horizon. Just as the moral history of humanity has gradually expanded its circle of consideration from the tribe, the city, the nation to humanity, animals, and ecosystem, the space age forces us to ask whether that circle can be expanded even further. The question will no longer be only how we should relate to other human beings or to our biosphere, but also how we should relate to possible forms of extraterrestrial life and to the environments that could make such life possible. At this point, astrobioethics fulfills an anticipatory role. It does not wait until we find extraterrestrial life to begin asking how we should act. Rather, it suggests that moral reflection must come before the discovery, because when that discovery happens, if it happens, decisions will have to be made under scientific, media, political, and economic pressure. Thinking in advances is a form of responsibility. An astrobiological vision would help guide that responsibility in three directions. First, toward the protection of possible forms of extraterrestrial life, especially if they are microbial, vulnerable, or unable to defend their own interests. Second, toward the preservation of astrobiological valuable environments, even when life has not yet been confirmed there. And third, toward prudent social communication capable of conveying the importance of the discovery without into exaggeration, ideological appropriation, or media distortion. So conclusion, astrobioethics lead us toward a broader understanding of life, of humanity, and of our cosmic responsibility. Astrobiocentrism expresses precisely this transition, leaving behind the idea that life must be thought only from our terrestrial reference point, and beginning to understand it as a possible reality in the universe. If one day we find life beyond Earth, even in its simple form, the discovery will not only change science, it will also require a new way of understanding our moral place in the cosmos. And that's it. Thank you.